Alright guys, welcome to this video. And if you've been following our series for some days now, we've been on number-based operation. We've been discussing the concept on number-based operation. And today we're going to be discussing converting numbers from base 10 to other bases, that is from base 10 to any other base other than 10. Are you with me? And if this is your first time coming across this video, I urge you to please like the video, comment on what you think about the video, and as well share to students that you think are having difficulties in understanding the concept of this topic. Let's dive into it. Now, if you remember, if you watched the first and the second video, we discussed about bases, and we said numbers are originally counted in a base of 10, which means if you are given a number that is not in a base of 10, if you are given a number that is not in a base of 10, your first task is to convert that number to a base of 10. Are you getting what I'm saying? And in today's video, we are going to be solving examples on converting numbers from base 10 to other numbers. Let's have some examples. So in the first example, we are asked to convert these numbers A, B, C to numbers in base 3. If you notice closely, 51 here is in base 10, 100 is in a base of 10, and 125 is in a base of 10. So all of them are in base 10. We are asked to convert them to base 3. Are you with me? Now the first task is to ask yourself the question, is this number in a base of 10? Luckily, yes, the number is in a base of 10, right? So we are just going to divide it by 3 because it is already in a base of 10, right? So let's have the first question. We have to convert 51 in base 10 to a number in a base of 3. So since this number is in a base of 10, I'm going to divide it by 3, and definitely there's going to be remainders. So I'm going to keep each of my remainders. So I'm having 3 and 51. So when 3 goes in 51, that's about 17 remainder 0. So 3 times 17 is 51, plus 0 is still 51, right? Then we use 3 again. 3 goes in 17, that's about 5, right? Because 3 times 5 is 15. So it's going to be remaining 2. So I have a remainder of 2, right? And 3 can still go in 5, so I'm using 3 again. So 3 goes in 5 is just 1, remainder 2, right? So if you check properly, you see that this number is a small number. You cannot see 3 inside 1, right? So you stop at this junction and you pick your values from the last number here and you go up this way. Are you seeing? So I'm picking the last number here and I'm going up this way. So it means I'm going to have 1, 1, 2, 2, 0 in base 3. Are you with me? So it means 51 in base 10 is equal to 1, 2, 2, 0 in a base of 3. So if you notice, since this is base 3, the 3 must not appear in this place, or numbers bigger than 3 must not appear in the range. So B. So for B, I'm having 100 in base 10. I'm having 100 in base 10. I'm asked to convert this from base 10 to a number in base 3. So since this is already in base 10, I'm just going to divide it by 3, and definitely there's going to be remainders. So I'm going to have 3 and 100. So 100 divided by 3, that's about 33, because this time this is 99, remainder 1, right? And then 3 goes here, right? 3 goes here is 11, remainder 0, there's no remainder. Okay. And 3 goes there is 3, because 3 times 3 is 9, and then 11 minus 9 should give us 2, right? And 3 can still go in 3, right? 3 can still go in 3. So when 3 goes in 3, when 3 goes in 3, we are going to have 1, remainder 0. And 3 can go in 1, so we stop at this junction and we'll pick our values from the last digit down here and we go upward this way. So it means that our final answer should be 10201. 10201. 10201 in a base of 3. So it means that 100 in base 10 is equal to 10201 in a base of 3. And the third question, we were asked to convert 125 in base 10 to a number in base 3. Alright, so I'm going to divide, since it's already in base 10, I'm going to divide it by 3. So when you divide that by 3, 125 divided by 3, that should give us 41, right? So if you multiply 41 multiplied by 3, that should give us 123. What will you add to 123 to make 125? That's 2. So we have a remainder of 2 here. And when you divide 41 divided by 3, we have about 13. And then when you multiply 13 times 3, 13 times 3 should give us 39. What do we add to 39 to make 41? That's about 2, right? And then we go with 3 again. 3 goes there is 4, right? That's 12, remainder 1, right? 3 can still go in 4. So 3 goes in 4 is 1, remainder 1, right? 3 can go in 1, so we stop at this junction and we pick these values from here and we go upward. So we have 1, 1, 1, 2, 2, 1, 1, 1, 2, 2 in a base of 3. So it means that we are going to have that question 125 in base 10 is equal to 11122 in a base of 3. Alright, let's look at something else. Let's look at how we can convert numbers from other bases from bases to bases, right? It could be base 10, it could be base 3, it could be base 5, right? Let's look at numbers. Let's look at how to convert numbers that are not in base 10 to other bases. So we are told to want to look at how to convert numbers from bases to bases other than 10. That is, we want to look at how to convert numbers that are not in base 10 to other bases, right? And look at the example given here. We are asked to convert the following to the corresponding base. And A, we have 1032 in base 4. We have to convert this one to base 2. You notice that it is not in base 10. We have to convert 1034 in base 5 to base 3. And if you notice, it's not also in base 10 as well. And then we have to convert 4035 in base 6 to a number in base 4. If you remember what I told you in the beginning of this video, that every number is originally counted in a base of 10, that is the denary system. And that denary system is the basic system of counting. So it means any number that is not in this system of counting must first be taken back to base 10 before any other conversion can be carried out. So if you check properly, this question was not given in base 10. So it means we have to convert this one first to base 10. When we are done with that conversion, we now change it back to base 2. Are you with me? We convert it back to the original system of counting, then before we carry on with the rest of the conversion. So question A, we're having 1032 in a base of 4. We have to convert this to a number in base 2. But first, I can't take this directly from base 4 to base 2. This has to be in base 10, right? So my first task is to convert this one to base 10, right? So first, I'm going to convert 1032 in base 4 to a number in base 10, right? And how do we change numbers, or how do we convert numbers to base 10? We said we multiply each of the digits by what is there, right? Multiply each of them by the old base. So I'm having 1 multiplied by 4, 0 multiplied by 4, 3 multiplied by 4, and 2 multiplied by 4. So I'm having 1 multiplied by 4, that's this and this, plus 0 times 4, plus 3 times 4, plus 2 multiplied by 4. So I can add powers of 10 starting from the right hand side on top of the base, which is 4, on top of each of these 4, starting from the right hand side with 0. So on top of this one I'm having 0, this one I'm having 1, 2, and then 3, right? So I can secure this. And if you work properly on this, 4 raised to a power of 3, that is 4 in 3 places, that's 4 times 4 times 4, that's about 64. And 64 times 1 is 64. And then 4 to the power 2, that is 4 in 2 places, 4 times 4, that's 16. And 16 multiplied by 0, any number times 0 is just 0. And then 4 in 1 place, that is 4 to the power 1 is 4, times 3 is 12. And we have 4 to the power 0 is 1. Any number to the power 0 is 1. And that 1 multiplied by 2 is 2. So when you add 64 plus 12 plus 2, you have 78. This number now is in base 10. Now, it is this number I'm converting to base 2 from the question. Now I can convert 78 in base 10 to a number in base 2. Are you getting the point now? The first thing you do, if the question itself is not in base 10, your first task is to change it to base 10 before you carry out any conversion. And since the number is already in base 10, I'm just going to divide by the new base, which is 2, right? So I divide by 2 and keep my remainders. So I have 78 divided by 2. So when you divide that, 78 divided by 2, that's about 39. It's an even number, so there's going to be a remainder of 0, right? And when 2 goes there, 2 goes in 39, that's about 19, because 2 times 19 is 38. So 38 remainder 1, right? Remember, we are dealing with base 2, right? Which means all the numbers we must have must not be up to 2. And then when 2 goes in 19, 19 divided by 2, that's 9, because 2 times 9 is 18, remainder 1, right? And then when 2 goes in 9, that's about 4, remainder 1, right? Because 2 times 4 is 8, plus 1 is 9. And then 2 goes in 4 is 2, remainder 0, right? 2 can still go in 2, right? So I go with 2 again. 2 goes in 2 there is 1, remainder 0. So once I get to 1, 2 can't go in 1. So I pick my values from here and I go upward, right? So it means I'm having the last digit here 1 0 0 1 1 1 0. So I'm having 1 0 0 1 1 1 0 1 1 1 0. In what base now? This number is in the base of 2. So I can say that the first question 1032 in base 4 is equal to 1 0 0 1 1 1 0 in base 2. Are we getting the point now? Alright, for question 2 or for B, we are having 1034 in base 5 we have to convert that to a number in base 3. So the same principle applies. Since the number is not in base 10, we first convert to the original system of counting, right? Then we divide by 3 and keep our remainders. So we have 1034 in base 5. I'm asked to convert this to a number in base 3. But first, I'm going to have to convert this one to base 10, right? So first, I'm going to convert 1034 in base 5 to a number in base 10, right? So what do I do in base 10? I multiply each of these digits by the old base, which is 5. So I'm having 1 times 5 plus 0 times 5 plus 3 times 5 plus 4 times 5. So on top of the old base, I'm adding powers of 10. So on top of this, I'm having 0, 1, 2, and 3. So I can secure this. So when I multiply 5 raised to 3, I'm starting my operation from this first bracket here. So 5 raised to power 3 is 5 in 3 places. That's 5 times 5 times 5. That's about 125. If I'm not mistaken, yeah. 125 times 1 is 125, right? Then plus 5 raised to 2. That's 5 in 2 places. That's 25. And 25 times 0 is just 0. And 3 times 5 raised to 1 is 5. Times 3 is 15 plus 5 raised to 0 is 1 times 4 is 4. So I'm having 125 plus 15 plus 4. I'm having about 144. In what base now? In base 10. So it is this number now that I'm going to convert to base 3. So I'm having 144 in base 10. I'm converting this number now to a number in base 3. And here I'm just dividing by 3 since it's already in base 10. I'm going to divide by 3 and keep my remainders. So when you divide that, 144 divided by 3, that's 48. Remainder 0. And when 3 goes there, that's 16. 48 divided by 3, yeah, that's 16, remainder 0. And when 3 goes there, when you divide 16 by 3, you have 5. Because 3 times 5 is 15. So that means we're going to add 1 to make 16. So we have remainder of 1. And 3 goes in 5 is 1, remainder 2. Right? So when you do 3 times 1 is 3 plus 2. You get this 5 back. So 3 can go in 1. We stop our operation at this point and we pick values from here and we go upward. Right? So we have 1, 2, 1, 0, 0. That's 1, 2, 1, 0, 0. So we have 1, 2, 1, 0, 0 in base 3. Are you getting the concept now? So it means that that question 1034 in base 5 is equal to 12100 in a base of 3. And the last question for this video, we're asked to convert 4035 in base 6 to a number in base 4. Let's have the solution. 4035 in base 6, 4035 in base 6 to a number in base 4. That's the question. But first, I'm going to convert 4035 in base 6 to a number in base 10. And to do that, I'm multiplying each of the digits in this number by the old base, which is 6. So I'm having 4 multiplied by 6 plus 0 multiplied by 6 plus 3 multiplied by 6 plus 5 multiplied by 6. So on top of the 6, that is on top of the old base, I'm adding powers of 10. 0, 1, 2, 3. And I secure this. So I first work with the power first before I simplify with this. So I'm having 6 times 6 times 6, that is 6 in 3 places. That's 216. So 216 now multiplied by 4, that's about 864. So this bracket alone is 864 plus 6 to the power 2 is 6 times 6, that's 36 times 0 is 0, plus 6 to the power 1 is 6 times 3 is 18, plus 6 to the power 0 is 1, and 1 times 5 is 5. So when I add this up, I have 864 plus 18, 864 plus 18 plus 5. I have 887. Are you seeing that now? So this number is now in base 10. So I'm converting this one now to a number in base 4. So I'm having 887 in base 10 to a number in base 4. And since it's already in base 10, I'm just going to divide by 4. And of course, I'm going to keep my remainders. So when you divide 887 divided by 4, that's 221. What kind of remainder is there? So you multiply 221 times 4. 221 multiplied by 4, that's 884. What will you add to 884 to make 887? That's about 3. So we have a remainder of 3 there. Are you seeing that? So when you do this times this plus this, you get this answer back. So we do 4 in 221, that is 221 divided by 4. That's about 55. You have your remainder. But what kind of remainder is there? So you multiply 4 times 55. What would that give you? 4 multiplied by 55. That's 220. What will you add to 220 to make 221? That's 1. So we have a remainder of 1. And then 55 divided by 4. That's about 13. What kind of remainder is there? You multiply 13 times 4. 13 multiplied by 4. That's 52. What will you add to 52 to make this 55? That's about 3. Right? And then we go with 4 again. 4 in 13. That's 3. Remainder what? 4 times 3 is 12. What will you add to 12 to make 13? That's 1. Are you seeing that? So 4 cannot go in 3 again. You can't see 4 inside 3. 3 is a small number. So we stop there and pick our values from here. And then we pick them all the way up. So it means our answer is going to be 3, 1, 3, 1, 3. That is 3, 1, 3, 1, 3. 3, 1, 3, 1, 3. Right? In a base of what? In a base of 4. Right? In a base of 4. So it means that question 4035 in base 6 is equal to 31313 in base 4. Thank you for watching and see you on the next one.